Okay, so members, we are going to see now more of functions and its derivatives, such integrals. We are going to see more of them in this lesson, but please don't forget to subscribe to the channel. Now, a function's derivative means there is something that we differentiate and that function is already there. We are going to see how do we apply them here. So, if I'm to handle this one, you see that when I differentiate the whole of the thing in the denominator, I get what is up there. So that one, call it a function and its derivative. So you let that thing to be a u, the one that you differentiate. So you see, I said let u be 1 plus sine x. So when I differentiate, this will be 0. When I differentiate sine, I got cos x dx, and you see already it's there. So now this integral will be integral now. Where is this? I put du over the whole of this is u. And this one you see when you integrate this, you get natural of u plus the constant. But our u was natural of 1 plus sine x, then plus c with ease. When I come to this, you see that the problem is that whenever you have any power which is not 1 on angles, that is a problem. So you try always to remove that angle, that power. So that when I differentiate this angle, I'll be adding to x. So I have already my x there, so it's a function, it's the derivative. What we do, we say you let u be that angle. So now u is going to be 2x dx. So now you see, now if I went by 2, my du over 2 is going to be x dx, which was already there. So now my integral there is going to be now integral du over 2 the whole over 1 plus now sine u, which will be now integral, when I move this out, du over 1 plus sine u. Now from there, we are going to use that t formula to handle this, because you see that from here, already you start by defining your t. So from here, you see that your t is going to be tan the angle here, then by 2 over 2. So you see that now I need to differentiate this. So your dt is going to be, when you differentiate this, you get half sec squared u over 2, then du. Because when you differentiate tan, you get sec squared, but when you differentiate this angle, you get a half, you not right there. So from here, it's that this 2 dt is going to be 1 plus tan squared u over 2 du. This is for sec. So that now my dt over 1 plus, but tan, your t is there, t squared is going to be my du. So from there, my integral is going to be a half. Now integral, the du is 2 dt over 1 plus t squared, the whole over 1 now plus the t formula for sine is 2t 1 plus t squared. So that this 2 will cancel that. So now, if I cross multiply here, up and down, I'll be having my integral is going to be integral dt over 1 plus t squared over 1 plus t squared plus 2t over 1 plus t squared. And so this is going to cancel that. So this will give me integral of dt over, now you see that if we expand this, we can be, okay, t squared plus 2t plus 1, which is the same as dt over 1. This is the same as t plus 1, the whole square. If I expand this, I come to this. But we have seen how we integrate this. So this is very easy. It's going to be negative 1 over t plus 1. So what is our t? So from here, now my integral is going to be negative 1 over t plus 1. Now we remove t. Our t was negative 1 over our t, which is tan u, but our u still was x squared over 2, then plus 1, then plus the constant of integration. So that's our integral there. When it comes to this, the same idea as the function is derivative. Now, so that here we can use the sign substitution. So this is going to be integral of x squared dx over square root of, it's the same as 4, then minus, I can write this as 3x power 3, the whole square. If I put 3 power 2, it will be 9, then x power 3, and then this 2 will give me x power 6, and from there it says the function is derivative. Now, so what I'm going to do is that here I have 2 squared, so I'm going to say let the whole of this 3x cubed be 2, because we base on the profit, or we base on this to know what our sign is going to be. So 2, then sine u. Okay, so from there we differentiate, and I differentiate this I get 9x squared dx equaling 2 cos u du. And from here, you see my x squared, the x is going to be 2 over 9, then cos u du. Putting them back there, and now my integral is going to be 2 over 9 cos u du over square root of 4 minus 3x cubed is there as 2 sine u by the whole square. So to put this constant out, we have 2 over 9 integral cos u du over square root of, this will be 4 minus, when I square this 2, I get 4 sine squared u. So this will be now 2 over 9 integral cos u du over, if I price out this 4, we are going to be having root 4, then root of 1 minus sine squared u. And this will give us 2 over 9 cos u du over, this will be a 2, then all of this will be square root of, this will be cos squared u. And from there, you see that this will be, this 2 will go away, but I have 1 over 9 integral cos u du over, this will go, so I have cos u. So that cos u is going to vanish. This will give me 1 over 9 integral u, which would be 1 over 9 u plus c. But what was my u? You go back from here. From here is that your u from here. So that your 3x cubed over 2 from here is equaling to sine u. So if you want to make the something, it's that your u is going to be sine inverse of 3x cubed over 2. So meaning that my integral will be 1 over 9 into now my u, which is sine inverse of 3x cubed over 2, then plus a constant of integration. So members, that's how we handle those integrals. Don't forget to subscribe to the channel. I wish you the best.